All right, so this is the second part. That's why it's 5.2b. And so yesterday we did the in-center, so today it's the centroid. They put them all in one lesson, but I thought it'd be a little bit easier for us to just split them up. So the centroid. Before we even talk about where the centroid is and how to find it, let's talk about what are we going to talk about? Oh, okay. Almost forgot about it. All right, we're going to talk about the median. The median. All right, so what I'm going to do is I'm going to draw. Let's see. Let's do this. Yeah, let's draw a triangle. Might as well. Let's just draw it like this. Draw it like this. All right, you ever go down the road and see that grassy area between two roads, right? You're going one way, traffic's going the other way, but then you got this grassy area in the middle, or sometimes it's a cement area. What do you call that thing in the middle of the road? Nobody knows? Take a wild guess, because I've said the word. It's the median. Very good. All right, so that's the median. Let's write that down. Median, M-E-D-I-A-N. So, if you're going down a road, well, you know what it is. I described it for you. I don't have to draw it for you. All right, the median is that grassy area. It's in the what? It's in the middle. It's in between the two, right? So it's in the middle. So what we're going to do is this. We are going to draw, and I'll do this on GeoGebra in a second, but let's just talk about what median is, and then we'll do the GeoGebra thing. So the median starts at a vertex, okay? Put it right there. So it starts at a vertex, and it goes, I'll tell you what, before I do that, let's do this. Let's find out where the midpoint is over here. The midpoint is right there. Oops. There we go. All right, so the midpoint of that side would be about right there. So now, if I was to draw the median, where would I draw it? I would draw it from the vertex. Where to? You have a math question? Is this a math question? Okay, don't ask it then. So, I know I'm being harsh, but I'm in the middle of something here. So look, it goes from the vertex to the midpoint of the opposite side. Everybody see that? This is a midpoint. Boom, boom, right there. That's a midpoint. So this right here is one of the medians. How many medians do you think it has? It's got 3 of them. That's right. And what do you think they do? They give me a good math word that we've used a couple times, well, 3 times already. If 3 lines meet at the same point, what are they? They're concurrent. So what do you think might be true about all 3 medians? They're concurrent. That's right. They meet at the same point. All right? And they do. Hunter, what did you need? Well, fill out a pass. Bring it up to me. You know the drill. All right. So now let's jump over to GeoGebra. So let's click that. Click that. There we go. It's early in the morning. I think you wouldn't have to go till like second or third period. Or this is second period, isn't it? I guess this is second period. All right, so let's do this. Let's draw a triangle, and let's draw the medians of the triangle. All right, so boom, boom, boom. It doesn't matter, right? Just draw just basic acute triangle. And then what I want to do is I want to find the midpoint of each of these 3 sides. All right, I got a little thing down here right there. It says midpoint. So I just click on that line. There's the midpoint. Click on that one. There's a midpoint. Click on this one. There's a midpoint. Now, what am I going to do? I'm going to connect from the vertex where? To that midpoint. Okay, right there. So that's one what? That's a what? What's that? What's line segment AE? It's a what? It's a median, right? Okay, it's a median. That's what we've been talking about. So from a vertex to the midpoint of the opposite side is a median. So let's do that. We said there's 3 of them, right? So let's do it 3 times. Let's go from this vertex to this opposite side to the midpoint. Let's go from this vertex to the opposite side. What did we say they should do? they should all meet, right, at a common point, which means they're concurrent. And all four of these things that we've done so far have been concurrent, haven't they? All right? And that's why they put them all together, because they have that in common. So what I'm going to do now is I'm going to put a point right there. Now, I'm going to do... Okay, so that's how you get... And I'll tell you what, let's click on that. Let's see. I think if I click on this, yeah, I can change the name of it. And what do we call that point right there? Centroid. The centroid. Okay, so there's our centroid. I'll just put it right there so we can read it. Everybody good? All right, so we know how to find the centroid. How do you find the centroid? Draw the what? The medians. Good. Okay, draw the medians. What does a median mean? Goes from the vertex to the what? Midpoint of the opposite side. Okay, that's what all these points D, E, and F are all midpoints. Right? And so we've got it right there. That's our centroid. Now, there's something special about this centroid. It may be something that you could look at and guess is true, but I kind of doubt it. So I'll just tell you. All right? See that centroid right there? Do you see the little line segment from the centroid to E and then from the centroid to A? There's a relationship between the lengths of those two line segments. From the centroid to E, from the centroid to A. Let's take a wild guess. There's a relationship, and it's a fairly easy relationship. Are they equal to each other? No. What'd you say? It's half the size. Exactly right. CE is exactly half of what? A, we'll call it C for A, well, even though there's a C down there, but we'll just say C for centroid, okay? So from here to here is actually half from A to the centroid. Or you could say it the other way around. You could say what? From A to the centroid is what? Double or twice, right? This little bit right here. That's a good observation, and that's true. Do you believe me? You shouldn't believe me. Good. Be skeptical, all right? I'll show you why. And it'll take a second to do this, but it shouldn't take too long. So what I'm going to do is this. I am going to get rid of, I'm going to keep the points, but I'm going to get rid of the line. Oops, I didn't want to do that. I wanted to click, there we go, click that line, click that, there we go, that's what I want to do. Because what I'm going to do is I'm going to break them up. Instead of one big long segment, I'm going to break them up into two smaller segments so that you can see, and we'll do the measurement of it, all right, and then we'll see that this one is double. So, oops, let's do this. Let's go to segment. Let's go from A to the centroid, all right, and then go from the centroid to E, all right? And let's just do the rest of them while we're here. We could just do one. That might be good enough for you, but I like to do all three. Right there, and then from there to there. It doesn't look much different like we had before, but what's the big difference now? Now, there's not just one big line. What is it? They're two segments, right? So I split it into two segments, right? So now this, watch, if I click on that, see how it just highlights from there to there? Yeah? And then if I click on this, it highlights from there to there. So they're two separate line segments. So what I want to do is I want to kind of show that the one is double the other, or the smaller one is half of the bigger one. All right, so what am I going to do? Come down here to measure. It says distance or length. So let's just do this one. I click on that. Now, you're going to have some decimals, all right? And in fact, I may have to extend the decimals out because it may not be perfectly half, but it'll be close enough, all right? Because, yeah, see, they said this is 4. This is 7.9. But 7.9 rounds to what? 8. And you're like, oh, I still don't believe you. Well, I think if I come over here to settings, I haven't done this since last year, there should be, dimensions, I don't want that. Well, is it one of these? Is it this? Well, I did it last year, and I just watched the video on it, so I didn't do it myself. Oh, there we go. Decimal places right there. So 1 decimal place. Let's take it to 2 decimal places, and let's see if that's any better. All right. It's not going to come out perfect, but you get the idea. All right. I'll tell you what, let's just do this. Let's make it 1 just so that we can see, and that should work. Let's go to this. Actually, not 1. Let's go 0 decimal places. And then we'll see. There we go. Okay, there. So this is 8. This is 4. So it's double this. All right. Let's do this one. Let's find the measurement of that one. That's 3. What do you think this one is then? 6. Okay. And I don't know which one you want to do. This one. 7. So this should be what? 3.5. But I changed the decimals, so it's probably going to go to 4. My guess is. Do you? Let's see. Boom. Yep, it did. Because I changed my decimal places, so it round to the nearest one's value. Is that what would you call that? Units. What is it? Whole number. Yeah, to the nearest whole number. That's a better way to say it. Okay. All right, you with me on that? And if I want, again, I could do this and maybe change it to like 2 decimal places. And you could get a little bit more accurate with that, but you get the idea. It's not quite as easy to see that this is half of this, though, is it? You'd have to probably put this in your calculator and then put half, and that's basically what it's going to be. But you get the idea. Now do you believe me that it's half? All right. Well, you better, Simone, because that was good enough. All right. So it's not really a proof, but it's just this little program putting the numbers in, and I think it's pretty accurate. So yeah, so that's going to be half. That's the thing that's special about it. Okay, it's just the lengths, the comparison of those segments of the median. All right, so that's what we're looking at. So, like I said, that's a little different than the special things that was true about the circumcenter and the incenter. It's a little different, but it's kind of cool to see that it works out that way. I believe, let me take a look in the book. I believe that's all I need to teach you for the Centroid. Yeah. Well, you know what they're going to do, right? For the problems, they're going to give you like the length of this one right here, and then you got to find the length of this one, right? Shouldn't be too hard, should it? By the way, you could move this around. Does it matter that it's an acute triangle? No. Look, I could make it obtuse. Tell you what, let's go back just to make, let's go to 0 decimal places just to make it easier for us to see. Now, again, you know some of them are going to be rounded a little bit. But see, there's 8, there's 4, there's the 7 and 3 again. But it all depends, right? If you stretch it out like this, now that one's 6 and 3, that's 10 and 5, that's 8 and 4. All right, so you can see that it works out pretty well. All right? That centroid, look, if I make it obtuse triangle, the centroid's still inside of the triangle, isn't it? Okay, if I make it acute, the centroid's still inside. If I make it right, it kind of looks like a right triangle right there. The centroid is still inside. Is there any way that I could make that centroid go outside of that triangle? There's no way. Okay, I could make it all kinds of different shapes.
I like the lines like super close together.
See, the centroid's still not going to go outside of it. Does it make sense? Okay. Let me show you one more thing. I'll tell you what, let's do this. Let's go back to my other program. Let's turn that on. Oops, there we go. All right, and let's go to this. Yeah, let's just use this. I'm just going to get rid of that word median, just to get it out of our way. And we know where it hits the other side is going to be the midpoint, so I don't really need to show that. We already know that this is the median. So let's do, let's just do this. I'll just do these in different colors. And I'm going to have to change it back again. Let's find out where the midpoint is here, just to be fairly accurate. This isn't going to be as accurate as GeoGebra. Oops, I should use my pen here. All right, and then let's do this. Let's find the midpoint here. That would be right there. All right, so now I'm going to connect from the vertex. Remember, the median starts at the vertex. and it ends up at the midpoint. All right, so let's do a different color now. Let's do this pink. All right, from this vertex to this midpoint, and it's pretty close, right? This program's not quite as accurate as GeoGebra is, but if I put a dot big enough, then they all connect at that point. Everybody with me on that? Okay. So this is what they could do. Let's stay pink right here. So let's call this A, B. So they could do this. They could say the length of AB is equal to 12. Notice I didn't put a little line segment bar over top of it, because when you don't have a line segment bar, what does that mean? It means the length of or the distance of, right? The measure of, any of those words are fine, of AB, okay? Now, we'll call that C right there at the centroid. So the question is going to be, what is AC? So this is a little bit more difficult. And what is CB or BC? We'll call it BC. So how are you going to do that? What do you think? Speak up just a little bit. Good. I'm glad you said that, because that's what I was going to get to. But you saw it right away. Look, the whole thing would be 3/3. 3 over 3 is 1, right? So it's the whole thing. This is going to be, AC is going to be 2/3, and then the BC is going to be what? 1/3. Everybody see that? Okay, because this is twice as big as this one. So watch. If it's twice as big, I could put a midpoint right there, couldn't I? So we'll call it D. So from A to D would be 1/3. From D to C would be 2/3. And from C to B would be what? 3/3. Okay? So each one of those is 1/3. But we don't really talk about, this one right here. Right? But we know this is 2/3 and this is 1/3. That's how they talk about it in the book. They use the 2/3 and 1/3. When I first teach this, sometimes that's too confusing. So I just say that the short one is half of the bigger one, okay? Or the bigger one is twice as big as the shorter one, all right? But then I did what we just did. I put a number in here, and you could figure it out. So what's the easiest way to figure out these things? You could go 2/3 times 12, or what's an easier way? You could go CB is what? 1/3 of the whole thing. So what are you doing when you're multiplying by a third? What's 12 times a third? It's just 12 over 3, isn't it? Yeah? So that's 4. So what's this going to be? 4. So now I can very easily find AC. So if I know this is 4, what's AC going to be? What is it? It's going to be 8. That's right. Okay? I could have done this. I could have said AC is 2/3 of 12. But I get the same exact answer, don't I? Look, 3 goes into 12 4 times. 2 times 4 is 8. Yep, I get an 8. So what I would suggest is that if they give you the whole thing, I would find the shorter one first. That's a lot easier. All you got to do is do what to it? 12 divided by 3. Okay? Once you get the shorter one, then you can just double it and find the other one. All right? That's really the hardest part, is when they give you the whole thing. But really, when you look at it, it's really not that hard, is it? Definitely, if they give you the longer one, it's easy to find the short one. Definitely, if they give you the short one, it's easy to find the long one. Okay? Now, what if they gave you the short one and they asked you to find the whole thing? Well, that wouldn't be much harder either, would it? Okay? You could just take it and do what to it? Multiply by 3, right, to get the whole thing. Or if you wanted to, if you weren't sure about that, you could always double it to get this one and then add the 2 together. You okay with that? Whatever way floats your boat, okay? However you want to do it. We good? I think that's it. That's Centroid. And I think we are finished all 4 of those triangles with the, I don't even know what they call them, like concurrent. I don't know if they give it like a special name for all of these. triangles with concurrent lines or something. I don't know. Let me see what they say at the very beginning of it. Now, they just call it circumcenter, orthocenter, and then incenter and centroid. They don't really give it like a general name. They just say relationships and triangles. That's too general. Anyway, you get the idea. I think we're good. So what do you need to do to keep all these straight? You need to study. Just read them over. Just read them over a couple times, all right? Like before you do a homework, read over your notes, all right? Make sure, even if you don't have a homework, just sit there and just read them over, okay? Put them in your phone, in your notes section, all right? Circumcenter. How do you find the circumcenter? What's special about the circumcenter? And so on. Do that, and then every once in a while, when you get bored, you got nothing to do, all right? Open it up and just review them. The more you review it, the more you go over it, then you're going to remember it.